Okay, the next equation we are going to discuss is the energy equation. We are just going to have a brief introduction of the energy equation because you will be studying it in more detail in the next course of the fluid mechanics, that is fluid mechanics 2. So the energy equation is based on the first law of thermodynamics. As you are all students of thermodynamics, so you will be in better position to tell me what is first law of thermodynamics, what's your understanding of first law of thermodynamics. Anyone who can explain to me the first law of thermodynamics, the statement of the first law of thermodynamics.
Sir, conservation of energy.
Conservation of energy. So the energy equation is pretty much that statement in the mathematical form. That is the statement written in front of you on your screen. Time rate of increase of the total stored energy of the system. If the energy of the system is increasing with time, so on the left side, the time rate of increase of the total energy of the system. And the energy of the system can be increased by two methods. What are those two methods?
Change of heat and work done.
Yes, is that by heat transfer and by work. So it should be equal to the net time rate of energy addition by heat transfer into the system plus the net time rate of energy addition by work transfer into the system. So if we have the system, let's say this is a system, it is a closed system. By system, its mass will be constant. It is a system. So only heat can enter or leave, that is Q in, Q out, and net heat transfer would be equal to, according to thermodynamics, what is positive? Q in is positive or Q out is positive?
So Q in negative है.
Q in is negative and Q out is positive according to them. So the net would be
Q out minus Q in.
Q out minus Q in. Similarly, the other interaction with the system is the work interaction. So work can be done on the system, that is work in, and work can be done by the system, which is positive and which is negative.
Work in is positive.
Negative.
Yes, which work is positive and which work is negative?
So work in is negative and work out is positive.
फिर heat reverse हो जाएगी.
Sir, work in is positive.
Work done on the system is positive and work out from the system is negative. As far as I remember, work output by the system is considered as a positive thing.
Yes, sir.
Right.
Work done by the system is positive.
Work done by the system is positive and work done on the system is negative. So this is basically negative. So I believe the heat part is incorrect, right?
So heat in is positive and heat out is negative.
Heat supplied to the system is positive and heat rejected by the system is
Negative.
negative. ठीक है? Now this is a convention made by us. ठीक है? इसमें परेशान होने की जरूरत नहीं है कि कौन सा पॉजिटिव होगा कौन सा नेगेटिव होगा. You need to stick to a certain convention. If you think work in is positive, then in all the cases, whatever you do, you should write this down that I think work in is positive and you should stick to it. फिर आपने से deviate नहीं करना. On the other hand, if you think work out is positive, then stick to that. ठीक है?
Okay, sir.
At the end, you will, whatever result you will get will tell us what is happening. You need to supply the work to the system or you will be getting work out from the system. You need to supply heat to the system or system will be releasing heat into the environment. Clear?
Yes, sir.
Because literature has its sets of convention. Literature has defined, okay, we take heat in as positive and heat out as negative. We take work in as negative and work out as positive. So based on that, you always decide that, okay, this is the convention and I will be getting if work out, if I'm getting the network as positive, it means that I'm getting work from the system. If Q net is positive, it means that system is releasing heat into the atmosphere, or I am supplying heat to the system depending on your convention. Clear? So work net is work out minus work in. Clear?
Yes, sir.
So the time rate of change of the energy in the system is dependent upon the rate at which the heat transfer is happening, that is heat is entering and leaving the system, and the rate at which the work is being done by the system and work is being done on the system, the net of it, right?
Excuse me सर, ये सर फिर ये जो हीट है Q net जो है वो Q in minus Q out होगा ना फिर?
Yes, it would be Q in minus Q out. It should be clear. So mathematically, this can be written as this. That is, the left side is what? It's the total derivative. अब इस लेफ्ट टर्म को थोड़ा सा समझने की कोशिश करते हैं. Just so the mathematical form of this statement would be this. What is the simplification of this term? What we are assuming that small b is equal to E, this small e, and the small e is basically the total energy. What is total energy?
Sir, sum of all kinds of energy, sir, potential, kinetic, internal, and working.
Thermodynamics perspective, what is total energy?
E in minus E out.
E in minus out, but what is it? What type of energy is coming into the system?
Sir,
What type of energy?
Sir, kinetic होती है, potential
Sum of
होती है,
all the
internal
internal,
होती है.
Yes,
kinetic and
the
potential.
internal. It is the internal energy plus, which is represented by U, plus the kinetic energy
That's the potential energy.
and the potential energy. Clear? So capital B would be equal to mass times energy, right? And mass is basically density into volume into energy. And if we're talking about the whole system, then it would be the integration of this B over the system, right? This would be basically integral rho E dV. And if I write it in the form of the Reynolds transport theorem, I would be having this would become basically B system. So D B system. So by dt would be equal to d by dt integral over the system rho e dv. Clear? Is it clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
And remember that small e is specific energy. What is meant by specific energy? If I ask you what would be kinetic energy, specific kinetic energy, it would be
Sir, energy per unit.
yes, v square by 2 only. Okay. If I ask you what is potential energy, specific potential energy, it would be g into h, right?
Yes, sir.
So this is what the first term is written like this. So and this should be equal to the net heat transfer into the system plus the net work transfer from the system. Clear?
Yes, sir.
Now, if you see this equation, we have assumed that Q in is positive, W in is positive, right?
Yes, sir.
Yes, sir, in this equation.
Assume how you assume. So if we assume that at any instant the system is coincident with the control volume, so whatever is entering in the system will be entering the control volume, whether it's the heat transfer or whether it's the work transfer. So the system concept would be equivalent to the control volume concept. So this d by dt integral E rho dv, which is the first term of the Reynolds transportation, should be equal to partial by partial t integral control volume E into rho dv plus integral of the control surface E into rho v dot nda. Is this equation clear? क्या इक्वेशन समझ आ रही है?
Yes, sir.
So what this equation is telling is time rate of change of energy in a system is equivalent to the time rate of change of the energy in the control volume plus the net flow of energy into and out of the control surface. Clear? Again, the first term is the unsteady term and the second term is the will only be non-zero when there is flow of energy into or out of the control volume. So the final energy equation can be written as like this, because we have proved that d by dt system is equivalent to q dot net in plus w dot net in. So partial by partial integral control volume into rho e rho dv plus integral of the control surface should be equivalent to what is entering in the form of heat and what is leaving in the form of work. Clear?
Yes, sir. Clear.
So this is just a brief introduction to the energy equation. Its applications are far more reaching as compared to the momentum equation or the continuity equation. All the thermal effects in your systems are encountered for energy equation. Like whenever you will be solving problems in some software, like you must have heard about ANSYS or you must have heard about MATLAB and the heat transfer problems. So what you will be doing, you will be solving the energy equation for the thermal effects, for the heat transfer effects. So energy equation is mostly related to the heat transfer effects. or the thermal effects. Clear?
Yes, sir.
Any question in this specific topic or in general to the question chapter number 5?
No, sir.
Is everything clear?
Yes, sir.
Yes.
So with this, we conclude our chapter number 5 and we conclude our course.